Well, good morning to you all. This is Frank Hartkamp speaking of RVO. We will start our first session of Groene Peper. The whole week there will be sessions until Friday. And this is the first session, so the starting session. Today we have Daan Terpstra of SDIA as a speaker. And he will give an introduction on green software. But first we have some general comments about Green Paper. So this is what Green Paper is all about. Next slide, please. The team is the organizing team. Next slide, please. And this session will be recorded and the chat function is on. So if you have any questions, please put them in the chat. And for sake of the streaming, please put out your camera and your phone. So please, Daan, you have the floor.
Thanks, Frank, and thanks for having me. I will talk you through some of the research that we are doing at the moment at the SDIA. I'll give you a really short introduction as what we are, the SDIA, and then take the next half hour, 45 minutes to take the floor and discuss with you what we are working on and how we are working on making best practices for making greener choices in green software. My name is Daan Terpstra. I'm with the SDIA, the Sustainable Digital Infrastructure Alliance, a European NGO based out of Hamburg and Amsterdam, collaborating in the Netherlands, or actually merged in the Netherlands with the former Stichting Green IT Amsterdam. What we do as an NGO is we drive collaboration across industry boundaries with our roadmap. Our roadmap is intended to paint the picture and the direction for a fully sustainable digital infrastructure by 2030. And how we do that, we collaborate through so-called steering groups and a network of like-minded organizations and individuals to drive new solutions to enable that digital infrastructure by 2030. One of those initiatives, and that is very like-minded to us and focused on sustainability in the digital realm, is of course why I'm here. So let me dive right into the topic of today. And what we are focusing at the moment is a lot on measuring and reporting the environmental impact of digital products and services. The digital transformation of society and industry is dependent upon a new type of infrastructure, digital infrastructure. We as a society are becoming more and more dependent on digital infrastructure. Our digital products and services are part of our daily lives, of our work, of our governments, of our energy and transport systems, and it touches everyone. These products and services are dependent on digital infrastructure and new infrastructure that is growing at an unprecedented scale. As with the previous transformations that we've seen in our society, for instance, towards a industrial society, we are now transitioning towards a digital society with a digital economy creating new growth opportunities. Industrialization created a thirst for electricity, and all of it, society benefited from increased investment into power grids and power generation. However, this infrastructure came with an environmental price tag with carbon emissions that we now need to rectify through the energy transition, adapting the power grid and generation to renewable sources of energy. As a further background, the US and Europe are responsible for the majority of global ecological damage caused by the overuse of natural resources. Now, with the expansion of digital infrastructure, we are risking to further expand the overuse of natural resources rather than reducing it by roughly 70%, the target needed to meet our climate targets. We do not know how much the environmental footprint of the Netherlands and Europe is increasing due to the investment into digital infrastructure and the use of digital products and services. And this is due to the fact that we are lacking the necessary tools, data, and research to have a clear understanding of the environmental burden we are creating for our current and future generations. Even worse, because we lack access to data and transparency, we cannot put strategies in place to reduce the environmental footprint, and we cannot innovate and we cannot innovate, and organizations are unable to account for the total environmental cost of their IT or digital services that they consume. The data exists. The digital economy, after all, is the most technicized, the most data-driven sector ever created. What we are lacking is the ability to connect the dots, to connect the entire value chain of digital infrastructure, from communication networks to data centers to server hardware to the software itself, and to attribute its environmental impact to the digital products and services that businesses and consumers are using. With this transparency that we are after, software companies can innovate to reduce their environmental impact. Consumers and businesses can choose more environmentally friendly products, and governments can put measures in place to limit the additional environmental impact created by the digital transformation of society. The Sustainable Digital Infrastructure Alliance, where I'm working for, is the only NGO today on the European scale which is driving this collaboration across the entire value chain to create this transparency on the environmental footprint of the digital economy and the products and services within it. As an independent body, we bring together organizations, governments, and academia to solve the challenges of measuring, attributing, and reporting the environmental impact of each part of the digital value chain, from infrastructure to software, from brick to keyboard. And we have a roadmap to underline this. So let's focus on the challenge, focus on the efficiency that at the moment the sector has a high degree of focus on efficiency, but that ignores, unfortunately, the total environmental impact. There is no lack of metrics to measure the efficiency in the digital infrastructure. Over the past decade, there have been many technical innovations pushing the energy efficiency of all parts of the digital infrastructure of the value chain, from hardware to communications network to data center. However, as William Stanley Jevons already realized in 1865, an increase in energy efficiency does not lead to a decrease of overall energy use, but it has the opposite effect. It drives further growth or further consumption. Further environmental impact goes beyond, moreover, environmental impact goes beyond mere energy use. It also considers the use of natural resources such as metals, water, rare earth, fossil fuels, and of course, it needs to entail pollution. However, to this day, the digital infrastructure steadfastly holds on to its obsession with efficiency. This can be seen in norms and standards governing data centers, as well as server hardware and computer chips. All of these measures of performance, measure performance in terms of unit per electricity, or is unit per carbon ton emitted. What is lacking across the entire value chain is an effort to measure or release absolute numbers. For example, the total energy consumption, resource use, or pollution. As most products and services outside the digital realm are adapting life cycle assessments to make the total environmental footprint known and the total resource consumption known, digital infrastructure, the value chain, focuses mostly on efficiency and on ratios. The most recent example is the launch of the Climate Neutral Data Center Pact, a joint effort of cloud and data center providers to self-regulate based on efficiency ratios. Absent in this regulatory effort is the release of any information on the total energy and resource use, as well as the pollution in the sector. Yet, these efficiency ratios and the existing landscape of metrics are insufficient to determine the environmental burden created by the digital transformation of industry and society, especially considered the aforementioned Jevons paradox, i.e. a higher amount of efficiency leads to higher overall consumptions. We must be able to have complete transparency in the energy and resource usage of the digital sector. Second, there is a lack of transparency across the supply chain. If we consider digital products and services as the final product which consumers and businesses can purchase, these products and services require information from their supply chain in order to assess their own environmental footprint and to make it visible to the end user, to the end consumer. A couple of examples on this lack of transformation. When it comes, for instance, to computer hardware, there are environmental footprints, reports, for instance, available from Dell or HPE. But both reports take a different angle at assessing the same problem, making sure that ultimately we cannot compare apples with apples, but rather that the current lack of a unified metric is comparing apples and oranges. When it comes to the virtualization and cloud infrastructure, is that, of course, over the last decade, computing and storage infrastructure has been abstracted in order to increase its overall efficiency, to have, so to say, many software applications run on the same physical infrastructure. This effort, however, has resulted in the inability of software applications to measure and read the energy consumption of itself, basically having a disconnect between the software and its actual energy use. This creates a barrier for software applications and thus for digital products and services to access the information they need to assess their own digital carbon footprint. And lastly, data center facility. One of the challenges and the lack of data and information that we see there is that in an effort to simplify the product offering and give IT infrastructure a maximum flexibility when installing their equipment, many data centers, especially co-location providers, offer flat rate power consumption contracts, regardless of the load that you're actually pulling at any given moment in time. As most IT infrastructure consumes less electricity than included in this flat rate, this has become a high margin part of the business for data center facilities to run, and thus creates an incentive for them to actually hide the actual power consumption. Now, in light of recent dynamics with regards to the geopolitical conflict in Ukraine and the rising prices of electricity, this is slowly but surely changing, but at least historically that was quite obscure. For software applications which deliver the digital products and services end consumers and businesses are using, transparency across the entire supply chain is a prerequisite, and both standardization and regulations are required to make the environmental impact information available. The methodology to derive this information in each part of the supply chain already exists today. It's the life cycle assessment methodology, and it is communicated and adopted by, amongst others, the European Commission. The next challenge that we see comes with the life cycle approach that has been validated. So the life cycle assessment methodology has been validated across the supply chain, but it lacks adoption. Across the digital product and services supply chain, this lifecycle assessment framework has been researched and in some cases validated. Yet actual adoption as an industry practice is still lacking, and therefore the results of this assessment in the same industry, as I highlighted before with Dell and HPE, creates varying results. Additionally, independent verification is lacking in all industry across the digital infrastructure supply chain. Many traditional lifecycle assessment approaches struggle with the complexity of a data center facility. So therefore, further work is needed to adopt an LCA approach to be more widely used across the supply chain. This is one of the efforts that we're pushing forward. And as a last challenge, to focus on electricity use and the shifting of responsibility to the energy sector. The narrative driven by most of the global large digital product and services company is that the majority of the environmental impact stems from the usage of electricity. Thus, the main action is to purchase green electricity. However, that is not required at the scale, that's not available at the scale required. This strategy can be witnessed by the fact that these companies are the top purchasers of so-called renewable power purchase agreements, PPAs, with, in this case, Amazon, Meta, and Microsoft leading the rankings. These purchases serve a dual purpose, which I think is very relevant to know: to provide green electricity for their operations, but also to lock in a fixed price for a long period of time, anywhere ranging between 5 to 15 years. One might conclude that it's an economic decision, as a significant portion of the operating cost of a cloud or data center stems from electricity purchasing. So rather an economic decision rather than a environmental friendly decision. Recent European research conducted as part of the SDIA project has shown that this narrative is ignoring the total environmental impact stemming from digital infrastructure. The embodied carbon and research usage is equally significant to the full electricity consumptions. Furthermore, this narrative assumes that by covering all of the operational electricity used by the use of green power contracts, the growth of the digital sector becomes sustainable, and with it, the businesses that make digital products and services. In one example, Google, for instance, claims to be carbon neutral already since 2007, which in our view appears to be difficult in the context of embodied carbon in IT equipment and server hardware alone. None of the 10 largest manufacturers of digital products and services make information on their total environmental impact publicly available in order to be verified. This only amplifies the higher need of more transparency. Within the last 3 years, there has been a noteworthy increase in pressure, however, from the digital sector on the energy sector to increase the availability of more granular green certificates as well as green electrons. The responsibility, however, is being shifted from the energy sector. The responsibility for becoming more sustainable thus is being shifted from the digital sector to the energy sector. If not enough green electricity is available, the digital sector is unable to meet its own climate goals. While this may be true, another solution could be an overall reduction of energy use, reducing the demand for electricity, which is more viable given the fact that almost every sector will require access to renewable energy sources. As the competition for renewable energy increases, so will that price. The digital sector has positioned itself well by purchasing almost all available green electricity already at lower costs with long-term price fixing, and hence a economically interesting model. Now, just to dive a little bit more into the context and the existing approaches on assessing the environmental footprint of digital products and services, what can we do and how can we measure green software? Now, due to the lack of information and the inability to measure the actual environmental footprint of software applications in cloud and IT infrastructure, most existing approaches rely on financial information to estimate the carbon emissions of digital applications. Some of these methodologies try to reverse engineer the IT equipment used to run digital applications from the invoicing information provided, for instance, by cloud infrastructure and IT infrastructure providers. Furthermore, most of them try to estimate the electricity used by those servers, as well as in which regions in the world or in a country they are located, in order to make an estimate on the carbon emissions stemming from the electricity consumptions. The accuracy of these methodologies are yet to be scientifically validated. Many of them have emerged over the last couple of years, and there is at the moment no actual energy and resource use measurement available for any of the larger providers of cloud and IT infrastructure. And hence it is very questionable whether the claims that they make can be verified. What is apparent, however, from these assessments, sorry, 1 second. My throat acting up, pardon me. What is apparent is that these assessments of these big, of the largest providers of cloud and IT infrastructure are being used to convince their customers that their offerings are less carbon intensive, and thus migrating to a cloud infrastructure by definition is the more environmentally sustainable choice. Purely from a resource usage perspective, this seems already paradoxical. As for example, a cloud provider must by definition purchase at least some new IT equipment in order which then of course comes with the use of new materials, in order to provide a enterprise with the infrastructure that they would require when moving to the cloud. At the same time, the enterprise then decommissions part of its IT equipment, which can only unfortunately partially be recycled. A more sustainable approach, for instance, could be to move the physical infrastructure to the provider, something that is at the moment at least not common practice. Most of the existing initiatives further focus on amplifying the importance of green electricity, as is, for instance, the case of Google's carbon dashboards. This dashboard is showing customers not their total electricity consumption, but rather the percentage of their electricity consumption covered by green electricity. Again, moving back to a ratio story rather than, in this sense, absolute numbers. So what's missing? What's missing is actual data on the environmental impact. The data industry has the least amount of data available on its own footprint. Yet it wants to help, and rightfully so, every other industry to understand theirs. With the Internet of Things, sensors, APIs, and cloud-based data storage, it seems to be possible to measure almost anything, except the absolute electricity consumption of data centers, servers, and networks themselves. This seems, at least in my view, a bit odd. It raises, however, an important question. If consumers, software developers, and businesses would have transparency and visibility on the environmental impact that their digital products and services uses triggers, would they make different choices? Would they reduce their consumptions? This way of thinking might actually explain why so many digital companies do not release any meaningful data on their environmental impact. It might be that it is fear that is, preventing them from releasing it, the fear of actually slowing down the massive growth of this industry, which we've seen for more than a decade. Anything that could risk this growth is ultimately not good for investors, not good for a startup, and not good for those companies. So why make the information transparent? That hardly anybody is asking anyhow. However, many governments and consumers are starting to ask for information on environmental costs that are critical for society to perform a proper cost benefit analysis. We need to know where digitalization can have a true net positive environmental impact. A first study in Germany conducted by the Border Step Institute aimed at understanding the correlation between increased digitalization and energy reduction already warns that the impact of digitalization is much less pronounced than often claimed. However, a lack of accurate information is making assessments inaccurate and difficult to do, highlighting the need for a more concentrated effort for measuring and reporting environmental impact, uh, and transparency is therefore needed. Um, so, if we then look at, sorry, just messing around, sorry, with my slide. Um, the key principles going forward, therefore, are transparency, trustworthiness, a life cycle approach, and open standard access to everyone, end-to-end measuring, open source, and impact focus. Transparency, meaning in this case, the methodology framework and calculations must be open and accessible to all stakeholders, and digital products and services are enabled to create transparency on their own environmental footprints. Trustworthiness means that all information gathered and reported must be verifiable and scientifically proven to ensure this trustworthiness. A life cycle approach means to utilize the existing life cycle assessment methodology and collaborate with academia to adapt existing frameworks to be applicable to digital products and services. An open standard means that, to create that it's accessible to all stakeholders and at no cost and is non-competitive. End-to-end, as makes sense, means that the entire environmental footprint across the entire supply chain is measured and accessible to all stakeholders. By open source, the methodology, tools, and frameworks should be part of the collective equity of society to support the reduction of the total environmental impact of the digital sector. And impacts focus means that it should focus on making the impact and the reductions there where it matters most, the most low-hanging fruit. The long-term vision for the environmental footprint is to capture all environmental impacts created across the value chain and attribute them to server-side applications and eventually the user's usage of that story. So what we are aiming for and what we're building at the moment with academia, with governments, and with for-profit companies is a framework to measure and report the environmental impact of digital products and services. A framework ultimately designed to make better environmental choices. Just to recap, there is no lack of data and metrics across the digital infrastructure system. The entire system has been built on data itself. The transparency needed must be open and accessible to all stakeholders in order to get towards proper and good and informed decision making. And lastly, we need to collaborate all experts, businesses, academia, and governments to deliver and implement this digital environmental framework footprint quickly. That's where DEF stands for. It is absolutely within the SDIA steering group's of industry, academia, and governments, we oversee the overall progress of the implementation of the digital environmental footprint, with working groups supporting that to develop the required technical deliverables that are needed ultimately for the assessment framework for all the subsystems in the supply chain. It is critical in this sense to not create redundancy in this work and to involve all experts from the field in a collaborative effort to deliver and implement the digital environmental footprint quickly. What I've tried to paint today as a picture is that the growth in digitalization, the growth of the digital product and services industry and its entire value chain does not come without a growth in the environmental impact of that sector. What is missing at this moment from the sector itself is absolute numbers, and we need to move away from the ratios in order to be able to make a true difference in terms of both policy as well as behavior to change the environmental impact and to reduce the environmental impact of the industry. Due to the complexity, the sometimes secrecy or obscurity of the data needed to make that change. Unfortunately, at the moment, end users, software applications, software developers have high amount of difficulty to assess their own environmental footprint, the resulting from their actions, from their line of codes and from their purchasing decisions. What we are working on at the moment is to build that framework step by step by measuring the digital environmental footprint and adapting the existing life cycle assessment methodology to fit the, in this case, digital realm. Ultimately, it would result in server-side applications being able to measure their own environmental footprints and allowing policymakers, politicians, purchasers, and perhaps even ultimately end users to adapt their choices of the digital products and services that they use to the one that they, for instance, may find A, economically most attractive, or B, environmentally less harming, whether you stream your cat video on one video platform or a second one that at the moment takes in mostly into account, for instance, connectivity or cost. The environmental impact of choosing Dailymotion over YouTube at the moment is unable, you as an end user or as a corporate customer are unable to make that distinction. That is what we are working on, and that's what we hope to achieve by the end of this year to provide that first framework to work on. And with that, I come to the end of my presentation. Before I go to the next slide on the end, I see a question from Monique. Monique, I haven't read it yet, so I'm just going to read out your question and then see to which extent I'm able to answer it. In any case, thanks for your question. Monique is asking, for those who do not have access to the chat, in what practical ways do you plan to bring about these changes and have organizations embracing and implementing these new frameworks? For example, training, education, doing projects with companies, etc. Well, thanks, Monique, for your question. There's two ways that we see basically to bring about these changes. One, and that's the most, from my perspective, the most important, is we work together with like-minded companies who are eager to challenge and change the status quo to show that a more transparent, environmentally friendly setup is more economically feasible. So, put it really simply, I truly believe that the whole story that I told today, at the end of the day, will reap more money for the companies involved, shareholders will be more happy. It's the logical economic decision on the long term. Second, of course, so that's the reward side of things. On the other hand, what is lacking at the moment due to the lack of data and insight is a proper regulatory framework, which I think is fully understandable given the fact that governments and regulatory bodies have very limited insights, and the insight that they have is on a very, very small portion of the value chain. So enlarging that would allow regulators, policy makers, politicians to make a proper regulatory framework to also stimulate companies. The one challenge that we see there is that in essence, in its very, very essence, the internet is global. So regulatory measures on a regional level, let's say Netherlands, or even Europe, may create a waterbed effect that moves these services rather outside of Europe with perhaps even more detrimental environmental effects rather than solving it. So that in and of itself makes the challenge very complex. That's why it's fun to work on. I mean, if it's easy, everybody would do it. But it's that's where we're aiming for. Monique, does that answer your question? I see a thumbs up. And I can see here by Rabbe Doormans in Dutch a quick testimonial on a tender, a RFQ for ERP software, where they asked also on the sustainability aspects of software, and that the one bidder that actually answered to the tender came with a rather, if I interpret it correctly, rather generic statement as, here's our yearly ESG report. Well, this is typically what we see all the time, right? I mean, so we as an NGO, we're using a suite of software, and we're asking every year to all our suppliers, okay, what's the carbon footprint of what we are using? And then they're saying, well, look at here's our ESG report, and we planted 400 trees in the Amazon, which in and of itself is absolutely fantastic, right? Don't get me wrong, it's great, but it's not answering my question.
No.
Fine.
Daan, I have another question. Maybe other people have questions too, so please put them on the chat. But I myself have a question. When you in your presentation you talked about the need for frameworks and measurements and all those things, but will this be enough for when you look nowadays at, for instance, the service, digital service, Bitcoin? Then everybody knows that Bitcoins use enormous amounts of electricity and it's not sustainable at all. But nevertheless, it's very popular, and people still like to buy those Bitcoins. So even if you know it, then the people will not change their habits easily. So what's your vision on this?
Yeah, no, I understand what you're saying, Frank, and there's two things here. I think that one is that it's not, I mean, yes, there is the Bitcoins use a lot of energy, but I don't really know it exactly what the full environmental footprint is of one Bitcoin mined where exactly. So I think still I have a, let's say, hope that more absolute data on the resource consumption of that mining in, for instance, leads to more informed decision making or better decision making from an environmental perspective of the end use. That's one. The second, however, I think is even more critical in my view. The sector, by its very nature and design, is dominated by engineers, which bring us fantastic, smart, and innovative solutions for complex problems which we were unable to comprehend, decades, years, or months earlier. It comes with one drawback, and that drawback is more often than not that we try to find the most optimal and best solution and invest significant time in actually understanding the problem for 100% and try to come up with a really good solution. Now, what we are advocating is from a software perspective, is a more iterative approach. Yes, our solution that we advocate is not going to solve it 100%. Absolutely. But it is going to put the first step in the right direction, and then we're going to approve, iterate, adapt, pivot, if you will, if something else is needed, and we'll work from there. The urgency of the climate impacts of climate change in general is too high to, in our view, to first come up with perfect solutions prior to implementing. I'd rather get to work and find in practice the drawbacks and the limitations of what we're offering here, and then adapt it. Oh, mute.
Okay, thank you, Dan. Maybe one last question from the audience. So if anyone wants to have the floor, please ask your question. And if not, then please, Dan, make your final remark, and then we will end this session. And the next session will start at 11.
Yes.
And the week will be sessions as well. So please, Dan, maybe one final remark.
Yes, thanks, Frank. Thank you for having me. Thank you, audience, for listening to me, the remarks and questions on the chat. That was much appreciated. As Frank said, the next one starts at 11. There's a whole week. I want to thank you all for your attention, your participation. One last remark. As I said, this is a joint effort of companies, individuals, academia, government institutions. At SDIalliance.org, you can indicate whether you want to help us with achieving our goal. We're always looking for motivated, smart minds to help us solve this problem, to crack this nut. And I particularly said not like-minded individuals, because we love and we like a very critical view. With that, this is the end of my presentation, and I think that we will then continue at 11 o'clock. Right, Frank?
Yes, thank you. Thank you, audience, and I hope to see you back in other sessions this week or other weeks. Thank you.
Thank you.